IoT-based safety gadget for child safety monitoring and notification. The main purpose of our project is to protect every child and to enhance child safety. First, we had generated the random values in the IBM Watson IoT platform. Our device type is named as RSVKA IoT device. Under this, we had created two events. One is to determine the random values of latitude and longitude of the child's location, and the other is to determine the random values of the child's body temperature and pulse rate. In this demonstration, we had assumed the name as child. These generated values can be viewed in the recent events of the IBM Watson IoT platform. Next, let us see the Python code for this project. We had imported time, sys, IBM IoT functions such as application, device, and so on. Then we had given the required credentials such as organization, device type, device ID, authentication method, and authentication token. Further, the program is executed and all the device credentials are stored under device options to make the program simple. The program also generates a random value for both latitude and longitude. The value generated as output in this program is also published in IBM Watson IoT platform. The statement is printed as out of the geofence when the child is moving out of the boundary region. Now let us view the output of the Python code. The same values are also viewed in the IBM Watson IoT platform. Now let us see about the flow diagram in the Node-RED. First, we are getting the input values from the IBM Watson IoT platform through the IBM IoT node. It is obtained by giving the API key, authentication token, device type, and device ID. Thus, the values published in IoT platform is also visible in Node-RED dashboard. The connection is given to the functions from the IBM IoT node to set and get the values. Then one of its connection is given to the world map node, which helps us to view the location. Another connection is given to the most important node of our project, that is the geofence node. A geofence area is created in the node by the user with an in-area property. From the geofence node, the connection is given to the function node with the in-area function. Then it is passed through a filter to a switch. The switch divides the entire process into two cases. One is true and the other is false. The true case determines that the child is present within the geofence area, whereas in the false case, the child is present outside the geofence. It is also programmed in the function node to display the message as entry or exit, date and time, name, latitude and longitude. Whenever the child moves outside the geofence boundary, then a notification is sent to the parents or caretakers through fast to SMS. All the above data about the child are stored in cloud and database. The message payloads are used to debug the messages. In addition to this, we had also created another flow to monitor the health of the child. In this case, the parents can monitor the body temperature and pulse rate of the child, which helps the parents to save their child from unwanted diseases. To obtain the output of the flows, we can deploy them and view the output in the Node-RED dashboard. Now let us view the exact location and health condition of the child in Web UI. Copy the URL of Node-RED and paste it in the new tab ending with UI. In this web UI, we are able to view the schematic form of location and health of the child. This can be viewed in the mobile also. Copy this URL to the home page, then it creates a shortcut. Thus, it becomes a very simple and easy for the user to use as it does not require any laptop or PC. The screen shows the mobile view of the web UI. Now let us see the last but not the least part of our project, that is the MIT app. Here we have created a login page where we can enter our username and password to login. If we type wrong username or password, then it shows invalid credentials. If you are new to the app, then sign up or register your credentials and click on sign up. It automatically takes you to the login page. Then log in with your correct credentials and the home page gets opened, which consists of three options such as location, health and alert messages. When we click on location button, a new screen opens and it shows the latitude and longitude of the child's location. Similarly, when we click on health button, another new screen opens with the temperature and pulse rate of the child for health monitoring. Also, there exists another button named as Alert Messages. It also opens a new screen while clicking the button. The alert messages that are received from the child by pressing the panic button is received and stored in the screen. Now the screen is empty as the child does not click the panic button. That's all about the MIT app.